Hello everybody, welcome. This is May 2023, paper 2, and it's from time zone 1. Let's go on question 4, to question 4. 17 mark question. A large international sports tournament tests their athletes for banned substances. They interpret a positive test result as meaning that the athlete uses banned substances. A negative result means that they do not. The probability that an athlete uses banned substances is estimated to be 0.06. If an athlete uses banned substances, the probability that they will test positive is 0.71. If an athlete does not use banned substances, the probability that they will test negative is 0.98. So positive means that the athlete uses banned substances or they test positive. And negative means that they don't. Okay. Using the information given, copy into your answer booklet and complete the following tree diagram. So remember, this is a paper 2 question. They're bolding this just to remind you. It's not enough to simply write this out in the actual the test paper itself. You need to write this out in your answer booklet. So just make sure that that you do that. Okay, so let's work through this tree diagram right here. Remember, each of these are binary events. They either use banned substances or do not. One of these things has to happen, so the probability has to sum to 1. 100% of the people are either going to use or not use banned substances. So if this is 0.06, this must be 0.94. So they must add to 1 once again. Uses banned substances, this is right here along this branch, and then we'll go 0.71, and we know again these have to add to 1, so this should be 0.29. And then for this last part up here at the top, we'll need to use the information that they give us. So does not use banned substances. If an athlete does not use banned substances, the probability that they will test negative is 0.98. So 0.98. If they do not use banned substances, test negative, 0.98. But we do get some false positives. And there it is, 0.02. So all of these need to sum to 1. Okay, not a bad start. Part B, number 1. Determine the probability that a randomly selected athlete does not use banned substances and tests negative. Okay. So B1. So the athlete does not use banned substances and test negative. So and let's just multiply along the branches in this case. So does not use banned substances and they test negative. So in this case it's going to be 0.94 times 0.98. And I'm going to work that out just in the calculator that I have beside me. And this is I'm going to write it a little lower actually. So 0.94 times 0.98 equals 0.9212, or to 3 sig figs, 921. Okay. Randomly selected athlete does not use banned substances and test negative. Okay. And let's go to the second part of this question. If 2 athletes are selected at random, calculate the probability that both athletes do not use banned substances and both test negative. Okay. So in this case, whenever we say 2 athletes, you might want to think if it's dependent, as if, let's say there are 100 athletes gathered into a room and we look for 2 athletes, and in that case, the denominator would change. For example, in this case, it would be, well, 94 out of 100 times 93 out of 99, something like that, a dependent event where the probability of something coming after depends on what came before. In this case, we don't actually have that situation. We just have a general statement of the, what can we say, the accuracy of these tests. So if two athletes are selected at random, probability that both athletes do not use banned substances and both test negative. So we know it's 0.921 probability, or roughly 92.1% chance that an athlete does not use banned substances and test negative. So two athletes selected at random, probability that both athletes, in this case it's just going to be the probability that the first athlete is one that does not use banned substances and test negative. That's 92% of our population, 92.1% of our population. And if we were to go out and select another individual and ask, well, how often does this occur? Well, again, that would be 92%. So 0.921 times 0.921. And I'm going to work that out here. 0.921. And this is going to give us 0.848241, or 0.848. Okay. All right. So just to summarize once again, 92%, the probability that someone doesn't use a banned substance and test negative is 92.1%. If we were to look at two people and ask, okay, how likely is that to happen to two people that were chosen? Well, the probability that the first person does not use banned substances and test negative is, well, 92.1%, and then the exact same thing the second time. So we're just multiplying across. All right, part C. Calculate the probability that a randomly selected athlete will receive an incorrect result. Okay, so an incorrect result. Let's see. Let's find out what that would be. So if they were to get an incorrect result, there are a few different ways that could happen. You could not use banned substances and test negative. That's one way. Oops, sorry, I think I deleted something. There we go. And test negative. And actually we can keep that here. It was 0.9, what was it? 0.921 something. 0.94 times 0.98, sorry. 0.9212. Or someone can use banned substances and test negative. So they can essentially cheat the system and be seen as clean. And that happens for, well, the 6% that use banned substances, 29% of those are caught. So we take 0.06 and we multiply by 0.29. And I'm going to work that on the calculator that I have beside me again. 0.06 times 0.29. So 29% of these 6%, and that would give us 0.0174. So roughly 1.74% of the population, I guess. Okay, so calculate the probability that a randomly selected athlete will receive an incorrect result. Well, what can we say? Okay. Whoops, sorry, I made a mistake. Does not use banned substances and tests positive. Here we go. That seemed a little high. Does not use banned substances and you are tested and found to actually, after the results, it seems like you do actually use banned substances. So it'd be 0.94 times 0.02, 2% of the 94% of individuals. 188. Okay. So these people do not use, but they test positive, and these people use and they test negative. And these are the ways that we can get an incorrect result. So 0.0188 plus 0.0174. So I'll work it out here, I suppose. C1 So that would be 0.0188 plus 0.0174. 0174. This would be the total number of people that take part in these tests and receive an incorrect result. What do we have? We have 0.0362. Or if we wanted to write this as a percent, 3.62%. IB is fine with fraction, decimal, or percent on probability. Okay, so, sorry that one was a little longer, but the idea is this person's clean, but they tested dirty. This person is, I guess they're using substances, and then they test clean. So, adding these two values, these are the two ways that someone can get an incorrect result. Alright. And often on a paper too, this kind of transitions. Just reading the first part of this, it looks like it's a binomial. A random sample of 1,300 adults or athletes at the tournament are selected for testing. Calculate the expected number of athletes in the sample that will receive an incorrect result. Actually, this isn't a binomial. The next one looks like a binomial. C2. So this expected value is in our formula booklet, but expected value we can kind of think of through intuition as well. Expected number of athletes. Let's write this out. Expected number of athletes. What can we say? Roughly 3.62% receive an incorrect result. And if there's 1,300 people being tested, we would expect 3.62% of that 300 to receive an incorrect result. So let's take that value 0.0362. This is that 3.62% times 1,300. And let's work that out. I'm going to work it out on the calculator that I have here. 362 times 1,300. 1,300, and this would give us 47.06 or 47 athletes. Okay. Expected number of athletes looks good. Okay. For expected value, actually, unless they ask us to round to the nearest athlete, we would generally put to 3 sig figs. Just looking at here, they don't ask us to round to the nearest. So 47.1, I just have the mark scheme actually in front of me, and it does have as a final answer 47.1, but in brackets it says accept the too significant value of 47 for a final answer. So both are actually okay in this case, according to the mark scheme, but 47.1 is probably more common, as in right to 3 sig figs for expected value, even though it's a fractional amount. Okay, there we go. Here's the formula, if you want. Equals n times p. This is essentially number of trials times probability, or that 0.032 times 1,300. So this is the number of trials, number of individuals, probability of occurrence. Alright. Let's go on to part D. Team X are competing in the tournament. There are 20 athletes in this team. It is known that none of the athletes in Team X used banned substances. And then I suppose a sufficiently kind of cynical person would say that Team X is very good at hiding it. Alright. Calculate the probability that none of the athletes in Team X will test positive. So it's known that none of the athletes use banned substances. Okay. So that means that does not use banned substance. They belong to this group right here. Calculate the probability that none of the athletes in Team X will test positive. So they're within this group that do not use banned substances. What's the chance? Probability that none of the athletes in Team X will test positive. So none that will test positive. So let's put test positive as a success. So this is a binomial question. We have a set number of trials. We have a probability of success, which is constant across trials, and the events themselves are independent of one another. That's to say, one person testing positive doesn't influence the chance of someone else testing negative or positive. So set number of trials, probability of success remains constant, and it's also binomial, as in there's either a success or failure. I might wait for this just to pass. All right. So let's call test positive a success, and this is number of successes. Number of successes. So if we're dealing with a binomial, we have number of trials, we have number of successes. We're going to have to define our success, number of successes, and then we also have probability of success. So in this case, we have number of trials is equal to 20. Number of successes, the probability that none of the athletes in Team X will test positive. We don't want any successes. And the probability that none of them will test positive. What is the probability of testing positive? Is 0.02. 0.02. So this looks like it should be quite small. Quite small, I think. So let's work this out, and actually we'll go into the calculator to try to solve this. Okay, so calculator, menu, probability, distributions, and we'll use binomial CDF. Number of trials, we have 20 athletes. The probability that someone tests positive, so they are not using banned substances, and the probability that they test positive is 0.02, and we want 0 successes. Whoops. We want 0 lower bound and 0 upper bound. That means we don't want any range, we just want 0 successes. And let's find that out. Okay, 0.667, so 0.667608. So roughly 66.8% chance that, even though all of them are clean, it's about 2/3 chance that everyone will come away with a clean test. Some of them might get a false positive. So let's go back to the document and write that in. So binom CDF, and we have 20 trials, probability of success 0, 0, and the result of that is equal to 0.667608, or 0.668. Okay. Yeah, I think that's okay. Let's see. I think there's actually another way to possibly do this. So test positive is equal to 0.02. Let's just use binomial, I suppose, in this case. I think that's going to be the most straightforward, and it'll set us up for this one as well, I think. So let's do question E. Determine the probability that more than 2 athletes in Team X will test positive. So more than 2 athletes in the team will test positive. So this is still these individuals that do not use banned substances. This is the probability of success. I mean, it's not exactly a success to test positive, in this case at least. in most cases, generally. But we can define success. Success is, you can kind of think of it as probability of occurrence. Okay, so let's go ahead. We can use a binomial distribution once again. So number of trials, number of successes, which I guess you can kind of think about this as occurrences, and then probability of success. The only thing that is going to change in this one, we'll still have 20 trials. The probability of testing positive, given that you have not taken any banned substances, is still 2% or 0.02. The number of successes, in this case we have a range. We want a probability that more than 2 athletes. Binomial can be tricky, and to be honest, I'm glad I read this a second time. It's more than 2. So 0 athletes, no. 1 athlete, no. 2 athletes is still no. We want more than 2 athletes. So in this case, anything from 3 to 20 athletes. What's the probability that between 3 and 20 athletes test positive? So let's go ahead and go back to the calculator. So menu, probability, distributions, binomial CDF, 20 athletes once again, chance of testing positive 0.02. What's the chance that between 3 and 20 athletes test positive? In this case, a rather small number. Looks like 0.007069. So let's go back to the document and write this out. What did we perform? Binomial CDF, 20 trials, probability of success, and the range is from 3 to 20. And the result was 0.0070, so that looks like a 6, 0.007069. To 3 sig figs. Remember, a significant figure only begins after a significant digit. So this is 1, 2, 3, and so. Okay, so 0.00707. Here we go. Okay. Not a bad question. All right, everybody. I hope that was helpful, and as always, best of luck. Take care.